All right, I think we'll get started. I'm sure more people will keep on adding in and joining as we go. So first off, I appreciate everybody joining. It appears things are getting busier out there, and hopefully you guys are getting busy as well. And so again, appreciate you taking the time. Today's webinar is going to be focused on presses, press applications, talk about some challenges that press OEMs, press users face, as well as some characteristics of presses. We'll review some actuation options for presses. Of course, you have electromechanical as well as hydraulics, and then there's other. We'll get into going electric. There's a big push for that. We'll talk about that a little bit. Of course, we'll talk about some Kyntronics solutions, as well as some software and force control and some features there. Our target is about 30 minutes. It is being recorded. Mute everybody at the moment, and questions at the end, and use your chat as you please. So this is just a snippet of various presses. This is a very hot segment for us regarding press applications. All kinds of various industries, going from assembly and auto to appliance to ring bending, even the hemp world. This particular press is a 170,000 pound force press using 285K pound force actuators synchronized together on all kinds of various other applications. One thing to note is you can see how clean these are. You don't see hoses, you don't see pits full of oil and things like that. So the majority of these have replaced hydraulics, especially on the higher end. This particular one did replace electromechanical due to shock loading. The electromechanical actuator lasted months, and this particular actuator has been lasting for years. So just a little snippet to get your guys' wheels turning regarding applications and presses. So some of the challenges especially regarding actuator control, etc. There is an increased emphasis on going green. We're hearing it more and more. Hey, my particular customer requires a no hydraulic solution, requires an electric solution. We've heard that before. The challenge in the past has been it's really expensive, especially on a 20, 30, 40 ton presses. We'll talk through that. Work environment, of course, cleaner, quieter, less space is always a need. Higher machine throughputs, always a desire, always the faster, better. Improved quality, accuracy, etc. Maintenance, you need to increase your uptime. Excuse me. Connectivity is always big. Finding out what parts are being pressed at what load, etc. Higher demand for data, preventive maintenance as well, and of course all the above at a lower cost. Some characteristics to just kind of keep in mind as we go through the presentation. Precise control is always a need, of course, especially on the more sophisticated presses, diagnostics. High loads, 20, 30, 40 ton type presses is a characteristic. Of course, higher and lower presses are out there, but that's the sweet spot. A lot of presses have this particular need, and just kind of keep this picture in mind of the high speed with low force and high force with low speed. Quickly get into position, do your work, and then quickly get out of position and get ready for the next part. This type of characteristic is important. And it does take advantage of some of the hydraulic characteristics out there. So what actuation is available to you? Of course, you have this hydraulics. It's a proven technology, very robust. Keep in mind this hydraulic fluid is a nice feature. It's pretty much incompressible. No brakes required. Just use check valves. Very shock load tolerant. There's some things you can do regarding hydraulics, regarding the side loading compensation, etc. And it is a cost-effective solution, especially for some of the simple requirements. You just need a HPU and run some lines to a simple actuator in and out. Obviously, it gets more expensive and more complicated with the valving. Another solution we're all familiar with is electrical EMAs, electromechanical actuators. A lot of advantages with these as well. Very easy to control. Feedback, reference, error, your PI block, you're off and running. Everybody's familiar with that, tuning, etc. It's easy to modify your parameters and adjust as needed. It's easy to connect up to other field buses, power on demand. You move the motor, the actuator moves, you stop the motor stops. Of course, no hoses and no leaks. So another technology that that's one thing I forgot to mention is this audience is a little different than other webinars. This particular audience may not be familiar with Kyntronics and the technologies. We're going to do a little bit of dive into the technology for those that are not familiar with. So that's going to be a review for others. So and then there's a few new things as well in the presentation. So this starts the introduction to the SHA. Yes, it combines both of the best features of both the prior technology, hydraulic as well as electrical, and eliminates most of the challenges. And we'll get into that. It's very efficient, very reliable, no maintenance. So what is this technology? So it's relatively simple. Of course, there's more to it, but trying to break it down in simplicity. You have a motor connected to a gear pump. Spin the servo motor clockwise, it pushes fluid into the red, pushes the piston up, vice versa. Counterclockwise, it pushes the piston down. You can see the difference in volume. This is your reservoir out there to compensate for the rod volume. Again, it's a simple approach. There's no mechanical binding items, pretty much any strokes available. Our standard is up to 36 inches, and our standard also is up to 42 tons. Of course, they can be synchronized together to give you more capability. So the gear pump, just a quick look. Hydrostatic sealing is important. You have fluid covering all the surfaces. So there's a film of fluid everywhere, even on the shafts themselves. So again, there's no metal-to-metal binding. If done properly, again, totally covered with fluid, with a simple little film of fluid giving you that hydrostatic seal. The circuit is again simple. Every actuator is shipped with relief valves, both one on the extend side, one on the retract. So if you were to hit a hard stop or even have the actuator go into its own hard stop, it just has the fluid circulate here. There is some PLC logic. You may want to avoid having it run for over and over and over in this mode. It creates heat and those sort of things. It should be avoided. If it's electromechanical actuator, you don't have relief valves, you run into a hard stop, you get binding, you're going to get a fault and stop, shut down the system. Again, ours will continually run, and it needs to be handled in the PLC, and you can easily shut things down as needed. Optional valves, you have a cavity plug, check valve, solenoid to lock into position. 4-quadrant controls mentioned several times throughout the slide. Some of our competitors, they can't do 4-quadrant control. 4-quadrant control is important for that precision, flow, PSI. We're able to adjust appropriately when they get into position for accurate either speeds, position, or force. You also have optional pressure sensors. This gives you the ability to do force control as needed. And we'll get into that a little bit later as well. Look at the outside. You have your motor connected to the pump, manifold, and your cylinder. This particular configuration goes up to 3¼ inches in the inner cylinder. So you have, on this configuration, you have an inner cylinder and an outer cylinder. Between those, you have closed cell foam that compensates for the rod itself. And when you get above 3¼ 4, 5, and 6 inches, you'll have the external reservoir. You have your position device coupled directly to the rod. Again, in motion control, you want to have your feedback device coupled as close as possible to the mechanism that's being controlled, and we're doing that. Electromechanical, you have an encoder. If there were gears, it would go through all the gear train itself, and so you're far away, essentially, far away using your encoder. So we're much closer, better control, accurate control. Some may say, hey, yes, but you still have hydraulic fluid, and that's a big negative in a lot of companies. Well, hydraulic fluid compared to other technologies and other things that are in the plant, your HPU, there's a lot going on there with the motor running continuously. If there's a leak, it's going to continue to spew oil around until you hit that low level indicator. Also, the 5 horsepower gearbox, your gearboxes out there have fluid in them. So even if the worst case scenario, tow motor ran over the actuator, you only have 14 ounces of fluid-ish on the floor. Get a mop out, send a PO for the new actuator, and you're off and running. So there's not a lot of fluid inside the actuator itself compared to other things that are around the plant. Another advantage of the fluid is your product configurations. In order to fit in a lot of machines, it's always challenging. In electromechanical, you really have your parallel and your inline. Again, we're just moving fluid. We've designed and shipped all these configurations out there and many more to make sure they fit in the actuator. So you're just moving fluid around. So we have a lot of flexibility to make sure we fit in the machine itself. Down below, just a couple examples of an all-in-one enclosure into the attached to the actuator itself. Here's a 24-volt DC, which has the drive and motor enclosed in IP68 design, customer supplied motor, as well as a custom design. So one thing that we try to do here at Kyntronics, we have electrical engineering on staff, software engineers, hydraulic, mechanical engineers. We're very system oriented. We like doing things and avoiding ourselves and avoiding the finger pointing. So what we do is all the way from the beginning, we try to gather as much information as possible, size, appropriately sized. We're pretty conservative. Our application team is pretty conservative. We have standard drawings, standard harness drawings, standard layouts, etc. So we'll put everything together, standard software, and do the testing as close as possible to your needs, and ship and tune on the machine with you as desired. Regarding other technologies, just doing a little deeper dive into the electromechanical as well as the hydraulics. You look at these two actuators, they look very similar. In fact, when we used to be able to go to shows, people come up to our booth and say, what's so special about your electromechanical actuator? Well, you take the M out and you put an H in there. It's not mechanical. And they stay and chat for a while and try to understand what's going on. So this is just full of fluid, opposed to an electromechanical that's all gears, metal to metal. Electromechanical, they don't like the shock loading at all. All kinds of problems with shock loadings as well as side loadings. They require maintenance. There's a finite life with the electromechanical actuators. It's expensive to do force control. With ours, you just add a pressure sensor in here, small, inexpensive option, and you now have force control along with position control, etc. With electromechanical, you have to add an expensive load cell, conditioner, cabling, etc. Electromechanical requires a brake. backlash, preload, and when on larger loads, of course, they get pretty expensive. IP ratings are also a challenge for electromechanical. Just to keep on that same thing regarding reliability, on electromechanical, we're getting calls and we've replaced many electromechanical actuators that have been placed in the presses before and that have had issues and failed. For example, you can see on this cartoon, same mechanical binding, once that press gets into position over and over again, is happening. That's difficult to take into account and do your calculations regarding load. And that's just premature wear and stress on the entire mechanical system. With hydraulics, it's just fluid and pressure. The SHA itself is not load dependent. The EMA is load dependent. As load increases, life decreases. Cost is another challenge that was mentioned, especially in the 20, 30, 40 ton range. EMAs get extremely expensive and cost prohibitive in a lot of cases to go down that electric road, the green road. As you can see here, it's relatively simple. With our solution, it's just increasing the diameter of the cylinder, same basic design is there. So it's relatively linear increase when you get up into the higher loads. With the electromechanical, in order to get into higher loads, it gets a lot complicated. A lot of things get bigger and a lot of things get expensive and more inefficient. So that means the motor gets bigger, the drive gets bigger, and it's challenging regarding to meet those cost needs. So SHA advantages over the EMA, just hydrostatic, we talked about that. Reliable, shock loading is not an issue with hydraulics and the SHA itself. Virtually no maintenance. IP standard, IP65 is standard. We can go higher as needed. It's an efficient and cost-effective solution. Again, with shock loading, the force, it's just pressure over here, and there's also relief valves in case the force gets really bad. Just pops the relief valve and the rod moves. Hydraulics, most everyone's familiar with the challenges with hydraulics. Won't spend a lot of time on it, but of course the pumps run continuously. They're usually oversized. You know the story with pipes and hoses and this massive things. Requires more floor space. They're sized to run a finite amount of cylinders. For example, it's also difficult to upgrade. For example, if you have 4 cylinders and the HPU size for 4 cylinders, and a lot of times your process may only need 2 cylinders run at the same time, so you size it for that instead of all 4 cylinders running at the same time. And maybe down the road things change and you want to run 3 cylinders. Now what do? Or add a cylinder. You have to either upgrade the HPU or add an electric or something. It gets a little bit challenging to upgrade your process. And it's more costly to do coordinated motion. It's complicated to do coordinated motion. All can be done, but it just adds that cost and complication along with the field bus and everything else. Efficiency, this usually doesn't come into play, especially in the beginning. There's a lot of efficiency challenges with the HPUs itself, and you're comparing apples to apples. Usually people just look at the cost of the components compared, from quote to quote. And again, this is an intangible at the end of the day when somebody's looking at a line item on an income statement and they're looking at an electricity bill. And with HPUs versus without HPUs, it's significant at the end of the year. Just something to consider as part of the discussion at the end of the day, along with all the environmental challenges. So the SHA advantages, we've already talked about a lot of these. Of course, no hoses. There's no threaded connections, which are the enemy to the leaks. Power on demand. You move the motor, it moves. You stop the motor, it stops. It's a very efficient solution going from electrical to linear motion. Quieter, takes up less floor space. It's a very reliable solution. Versatile configurations. You can have a very accurate control, field bus connectivity. Again, all taking advantage of all the features of the electrical world with the SHA. So going green. So we're all familiar with this site and walking in this mess with boots or whatever you have on. It's a challenge, and it's of course brand new. It looks nice, and then they start adding these barriers and to keep the fluid inside, and over time it gets to be quite a mess. So again, your electric solution is the SHA going green. So there's two different types of languages, I guess, two different schematic symbols. And Kyntronics, we understand them both. We understand how to read them. We understand the electric. We have thousands of electric actuators out there today, so we know how they work. We're very familiar with the hydraulics and how they work. EMA companies, they're challenged to speak the hydraulic fluidly. Work with the customer, we'll ask the appropriate questions. We understand, for example, if there was a press doing just flow control, speed control, allowing a certain amount of flow into the actuator itself, going down, pressing on a relief valve. We understand that that's going to be a little different than doing position control. In some machines, because of the hydraulics, they're powerful. They just run right through some of the machine, not optimal machine mechanics. Position control will have, sometimes it'll have some challenges getting through the mechanics, and you'll have some instability, etc. So we're familiar with all that. We ask questions. We know what we need to do and we'll work with you to make sure it's put together correctly. Same thing, again, just to repeat, this is a recurring theme. Hydraulics and electric combined. The SHA, the features, absolute position feedback. You have integral force control, along with the proven software that's been developed for many years. Just something to think about is the press and hold capabilities. You can quickly get into position, lock in. You need to be able to hold 80,000 pound force. You can quickly get in there. You have your 6-inch cylinder, lock in with a solenoid or a check valve, and you can quickly get out. So again, for clamping and holding is another a nice advantage of hydraulics. Doing a little bit deeper dive into high speed, high force solution that we have available today. Kyntronics has two solutions. A 2-cylinder solution, which includes a small high-speed cylinder that does your fast move, and then your high-force cylinder. Just an example, 84,000 pound force running at 10 inches per second. That requires about a 360 horsepower HPU, and that would need to cover this entire range. Massive motor, hoses get significantly large, of course connectors, and it gets expensive. With our solution with these two design options, 10 horsepower SHA can do that. Again, you go low load, high speed, quickly switch over to the high force mode, your high force at the end of the stroke for at a low speed, and then quickly go back. High speeds in at 15 inches per second, high loads up to 42 tons standard. Of course, they can be parallel, coordinated motion, or quantum control, field bus, and servo, and all those are included in both of these concepts. So a little bit looking at both of these. So this is your high speed cylinder that pulls your high force cylinder. Don't worry about this too much. It just, the point is that it gets to be somewhat complex. Of course, with complexity, it becomes a little more expensive. So this is one of the more expensive, higher speed, high force, although it's still cost effective compared to the 360 pound force or horsepower, I'm sorry, horsepower motor you need. So higher speeds are attainable with this compared to the multiple pump approach and 4-quadrant control, and you're able to switch between position of force and take advantage of all the software available. The multiple pump is a second design. So this is more of the standard. So this takes pretty much the standard circuit. You look to the left of these gray dotted lines, and basically you add higher speed pumps. You control them coming in and out. So these guys are running higher speed at low load, so the torque of the motor isn't too high. And you switch back and forth. So this gives you the ability to be about 7 to 8 times the increased flow of our standard with the multiple pump approach. So again, 4-quadrant controls, which takes advantage of all the position and force control as needed. So these are very applicable solutions for presses. Again, majority of the presses that were shown earlier in the first slide or so are a standard design. This is just an option to get faster, and that's some of our challenge regarding the standard is speeds, and this is a solution to that. Software control, force control. How we do it, it's just a simple pressure sensor being added to the circuit. It can be in the extend or the retract side. For an EMA, you have to add an expensive load cell, conditioner, cabling, etc. So just keep in mind the SHA itself has the built-in, easily simple option for force control as needed. So when your press requires you to come down in a certain position and then switch over to force, we can do that with that simple feature. Or add option, the pressure sensor. Position control, force control, position and force control, all can switch at any time. It's seamlessly between them. You're not going to get interruptions. Position control with force limiting is the most popular. Force 4-quadrant control and synchronization. This is just an example of 4 40-ton actuators synchronized together to take care of your 150-ton requirement. So these are all, again, options that we can do, coordinated motion and custom programming, etc., as desired. So you say that, yeah, that's great. You have all that awesome software available, but my customer requires Allen Bradley and requires Rockwell solution, and we can't use anybody else's drives. So we solved that for you. We've taken all our software that's been developed over the years, and we've placed it into this AOI, this block. So I won't get into too much detail regarding the AOI, but it's basically you have all the features of it available that you have, that we have developed with the Rockwell solution. We're also working with Rockwell on a canned press solution. This is in development now. We're looking for some beta sites. This is getting launched. Basically, this is a canned approach with a Rockwell hardware and RAOI for press OEMs and users to use, again, this for their needs and adjust it as needed. So wrapping up, of course, the power of the pen. The SHA is the preferred solution regarding the challenges. We encourage you to do your homework, ask questions, gather data, etc. And we're confident that you'll come to the same conclusion that the SHA is the preferred solution, and the EMAs and hydraulics do have their challenges. They have their purpose, of course. They're all out there. But the SHA itself, for a lot of this converting to electric, is an excellent solution. So contact your salesperson, local rep, etc., and let us know if you have any questions. We appreciate you guys taking the time today. Any questions?
Carl, John Lemieux from Protos, Houston.
Yeah, John.
On previous webinars, someone had mentioned some of the markets to target were like dry ice, security barrier people, valve manufacturers. Is there anyone else that I'm missing here that you can think of?
Say that again, John. What's the other?
I'm just looking, when I'm looking for appointments,
Okay.
I need to look at different markets. And you had mentioned dry ice manufacturers is a good one. Security barrier people is a good one. Perimeter security, like for gates and stuff. Valve OEMs. I'm just wondering if there's anyone else that you guys do business with. I'm sorry?
There's a bunch of them, of course, and things are starting to open up today. There's AGVs are a big market. Interesting.
Who?
Automated guided vehicles.
Okay.
There's sometimes there's DC requirements that we can do easily, especially because we're efficient. We're getting more and more involved in those. Packaging industries, big. Of course, oil and gas isn't really taken off just yet, but valve controls and various things in that world and other process worlds that we've done. Those are just some examples. This particular presentation was focused on presses, but there's a bunch of different presses out there that require this type of product.
Another quick question. If we pick up a spec that says no hydraulics, we can still quote that, you think?
Yes, absolutely. Absolutely.
Okay.
Any other questions? I know there's a few things in the chat room. So Steve's asking about rod compensations. That's a difference of the volume of the rod itself. You have to compensate for that fluid as it goes, the rod goes in and out. So precision, we advertise thousands, and we can do better than that on various applications.
So on the rod compensation, you're saying, so like if I have 10,000 on one side and I have 8,500 on the other, yours, how does that work? I mean, is it a scalar or what happens?
So the rod compensation itself is your question, Steve?
Yeah, how does it work? I mean, is it how do we interface to that, or is that just?
It's invisible to you. There's nothing you
Okay.
can worry about. It's just the fluid goes into the reservoir, and it comes out. So the pressurizes the reservoir a little more when the rod's all the way when it's retracted, and then the reservoir lets the fluid go out when it's extended. So there's nothing you need to worry about. It's just part of.
So you're literally moving more fluid because you have less area, and then that compensates for it.
Right.
Okay, thank you.
So there's a question about the AOI for the Kyntronics servo drive. The AOI is for the Rockwell solution itself. So it's a Rockwell AOI that goes into the Rockwell PLC and works with the motion controller there. Scrap balers, we can definitely do the scrap balers. We haven't done any at this particular moment. I believe we've quoted some. So the AOI looks like there's some confusion on that. Again, the AOI itself is specific to the Rockwell. The software is that we've developed in structured text is in the NEDEC drive itself. That's our go-to drive at the moment. We do have a configurator for the SHA. We can share that as needed. And that's what we use internally. We don't require a multi-axis controller. We can synchronize things together through various means that we're doing today. What else we got here? So in order to hold position, do we need a brake on the motor? You don't require a brake on a motor. We don't use a brake on a motor. We use a check valve or a solenoid to hold position. Today, we do not have a hydraulic rotary solution. What else? So sizing, again, will work. If you gather the necessary items, load, speed, cycle time, stroke, we can put together a quick quote for you. No problem. And we can share the configurator as well. What did I miss? Did I miss anything? I kind of went through this relatively quick. Anybody else have any other questions? Well, if you think of any questions, feel free to contact myself or your sales guy or rep, and we'll help you out as needed. Thanks for joining, everyone. Appreciate your time.
Okay, thank you. Bye.
Thank you.